Dear students, today we will discuss the household electrical circuit. So, how these connections are made, we will just come to know here. So, here this is the lines which are coming from your electric meter. So, there are three wires. One is the of red color, that is called the live L, live. The second is of black color, that is neutral. This black is neutral. And third is of green color, that is of earthing. It is a thick one. So here it is the mains, which is at the beginning of your house. So this mains contains MCBs. These MCBs are called miniature circuit breaker. So that means these MCs will have different circuits. One room will have one circuit, the other room has another circuit, the washroom etc. will have another circuit, and the power lines will have another circuits. So these MCBs are of different, and they break or they get disconnected when some fault is taking place in that particular circuit. That means in particular room, they say you are doing some iron or you are having a mixie, and so the mixie wire gets in contact, and then there is a short circuit. So that particular MC will get triggered and it will break the circuit. So miniature circuit breaker, it will work accordingly, and rest of the rooms will remain as it is. They will function as it is. So this miniature will break when the current, the circuit in the regular circuit is 3 times to 5 times larger than the usual. So that time will get break. Now this live wire is like this, and then neutral wire is connected like this. And how the different components are connected, that I'll just tell you. The green wire is connected again separately. So here it is the first bulb. All these circuits have to be connected in parallel, not in series. If you connect them in series, if this bulb will get fused, the whole of the circuit will not function. That there will be a darkness in the room, the whole room. Whereas if you are connecting them in parallel, so what will happen? This bulb, and this bulb. If this gets fused, so the current will pass through. These will function as usual, and this will not function. But when you connect them in series, then what will happen? Either of the bulb is fused, then all of the bulb will not function. So that is why these components are connected in parallel. So this first component I am taking as a bulb 1. So this will be connected from live to neutral. So here you have to put the switch. So switch is to be always or connected in the live wire, not in the neutral. If you connect it in the neutral, what will happen? If you disconnect it with stop, then the bulb will go on off. But when you changing the bulb, by chance your finger or your hand gets touched with the holder pin, then you will get shock, because still the current is there. That is why the switch is to be placed in the live wire. So if you switch it off, and then if you touch the holder pins while changing the bulb, then there is no current. It is cut off here, so it is neutral, so you are safe. So mind it, the switch is to be placed always in the live wire. Now second bulb, again the switch is coming over here, so the circuit is completed. And again the fan, and now it is a 3-pin socket. 3-pin socket, this bigger hole is of earthing. So this green wire is to be connected to this pin, that hole socket, and this switch is connected with here. When it make it on, so this is to be connected here. in the inside board, it is connected here, and this is connected to the neutral. Similarly, if it is pin socket where you have to make the phone charger or something else, only two pins are there. So this switch is connected here, and this, when you make it on, this is connected to this one, and this black is connected to this one. So this all these switches are placed in a switchboard in a room. So that switchboard is like this. Here again, you just see the 3-pin socket. This is the 2-pin socket I told you, and this is the bulb 1, this is the bulb 2, and this is the switch for the fan. I'm taking this. There may be more components, so you can have more and more switches also there. So this is the line, the red wire that is connected to this switch, and internally all these switches are to be connected by a naked wire within these switches. Now this black wire is the neutral. This neutral wire is to be connected with this pin, and again this pin is there. So this socket may be attached over here, so this wire will be there. It is no problem. You have to take one more wire, and it is to be taken within this and connected here. Is back side of this switchboard. That's why I have shown it like this. This is not connect. It is not having any connection with these wires. It is just behind of these and connecting to this. Now this earthing is connected to be this bigger socket, this one, hole, the pin, earthing. And now these switches are to be connected, because this is line, this is the switch. If you have to make it on, then this switch is on, then it will connect to this, and this will be connected with the first bulb. Similarly, this is to be connected with the second bulb, and this is to be connected with the fan. Now the fan, a wire is to be connected from again, and this all are to be connected with the black wire, that is the neutral wire here. So this way, this is the complete circuit, and this is known as the switchboard. So you have seen how they are made. These wires are going through the wall, in the wall from the switch, and these are also from the wall. But how they are to be connected? They are connected like this. So this is the board, and the connection which are showing that how the switchboard is made, prepared, or connection are made there. And this is the electric circuit household, and this is the way how you have to connect them. This whole system is connected. All switches are from here, and the bulbs and fans are on the walls or the ceiling. So I think this is very clear.